Sets. This chapter is complete focus about analyzing set. If we say for set, set is nothing but a unique collection of items. It can be collection of a unique elements, and these elements are said to be called as the members. The two most important properties of the sets are the members of the sets are unordered and that no member can occur in a set more than once. Set, it always plays a very important role in computer science, but are not considered as a data type in many programming languages. If you have gone through concepts in algebra and many more, you must have definitely gone through a chapter which was a focused complete understanding for sets. Sets can be useful when you create a data structure. So it is useful for creation of a data structure which comprises of unique elements. This chapter discusses how to create a set class for JavaScript. Prior to that, we should understand that set is an unordered collection of related members in which no member occurs more than once. Set is denoted mathematically as a list of members surrounded by curly braces, such as we can say a number from 0 to 9 and so on. And it can also be written in the unordered form like 9085 and somewhat in that way. Let's analyze some of the set definitions. So we'll go through our next slide, that is understanding the set definitions. Set definitions mean some of the terminologies which are quite peculiar to understand before implementing JavaScript for set data structure. The first comes is the set containing no members is called as an empty set. Whenever you go through a terminology that we are telling that it is an empty set, it means that that particular set has no members associated to it. The universe is a set of possible members. If I say universe is a kind of a set which is an infinite set and it consists of a set of possible members. Two sets are considered equal if they contain exactly the same numbers. So it is like whatever members which I have, it has the same values. Like the way I mentioned for integers from 0 to 9. One has the ordered form, other has the unordered form. But both are equal sets because they have exactly the same members. A set is considered as a subset of another set. We have a subset terminology over here. And a set is considered as a subset of another set if all the members of the first set are contained in the second set. So if a second set has, say, I have one set which is from 0 to 9, another set which consists of values like 2, 3, 4. So 2, 3, 4 is a subset of the major set which I mentioned now, which is the integer values from 0 to 9. After this concept of set definitions and terminologies, the next point comes is understanding the set operations. So we have some operations like any other data structure has, like for addition, deletion and so on. In the similar way we have it for set. So set includes an operation like union. So first is the union. Union is nothing but addition. In simple terms, it is addition of two sets. A new set is obtained by combining members of one set with the members of another set. So you have two sets. You simply combine both these two sets by removing the duplicate values. Suppose set A has 2 and B also has 2. Then the resultant set, that is union of both the sets, will have only one value as 2. Intersection. Intersection means nothing but we are just removing the common paths. A new set is obtained by adding all the members of one set that also exist in the second set. It checks out that which members are common for both the sets and keeps that values in our subset. So that will be the intersected set. After this comes the difference. A new set is obtained by adding all the members of one set except those who also exist in the second set. So difference means nothing but you are just subtracting a value. Like if you have the common part, so you remove that common part and what part is left, that will come in this scenario as a difference. Now let's go to our code base where we will analyze the set structure. First thing we'll do is we will create a set demo, setdemo.js, and after that we'll link that particular JS file in the HTML file and we'll check for the necessary output. So let's go to our example where we will analyze the complete structure in our code base. Moving on to our code base where we will create the JS file for implementation of set. So this is our code base. Here I'll create a new file and save this file inside a folder. So my folder name will be new folder, that is sets. Inside sets, I'll create a file and the name of the file will be setdemo.js. As it is the demo file, so we are creating it right now. After this, I'll start with my set property, that is function set, and inside this I'll set the properties like this dot data store equal to blank array. After this comes add element, so this dot add equal to add. After this comes the next functionality is to remove, so I'll say this dot remove equals remove. So all the assignment operators are initialized in the proper constructor way. The last part is to display, so I'll display functionality will be taken as show. So this dot show will be show. So I've initialized my set. After this, I'll create a function for adding a particular value in set, so that will be done as function add, parameter will be data. So I'm adding a value inside a set. For this I will say if, I'll specify a condition, if this dot data store dot index of data, if the index of data is less than 0, in such a scenario, I'll create a logic like this dot data store dot push. So it will push the data, and after this will be returning the boolean value, that is true. Okay. Then comes the else part, which says return false, which means it is returning the false attribute for the addition. If I get the index as more than 0, then it will return the false attribute. So this was for adding up the data. The next point comes is for removal. So the removal will be as function remove data. Inside this I'll specify the value for remove, that is var pos. This is a position, so the position will get the index of the particular data. So this dot data store dot index of data, and here I'll say if position, if I get is greater than -1, which means that my index is greater than -1. In such a scenario, it will remove the data. So it will use a function, JavaScript function called as splice. So it will say this dot data store dot splice, and inside this it will specify the position as 1. So the first data inside the set will be removed, and after this I'll specify the parameter as return true. And if I find the other scenario over here that my position is not greater than -1, then it will return false. It means that it will not remove any kind of a value, which says that there is no such element available in the set, or it can happen a scenario that there is no element available in the set only. After this comes the next issue is for showing up the value. So I'll say function show. Inside show I will say return this dot data store. So it will remove all the data store elements which are available in the set. So this was for creating the elements which are available in the set. Now we should understand like each and every functionality. So this was for addition, where it was checking out like if the index, if we are getting it is less than 0, it means we need to add up. But here in the scenario, if we get the position which is greater than -1, or if I get a position which is equal to -1, in such a scenario it will return false and not remove the element. So this was the basic structure for analyzing the set demo, or we can say the set illustration with JavaScript. Now in the next chapter, we'll create a HTML file and the implementation with a sample example and check out the output in our browser. So let's move on to our next chapter.